So, I already know. What can you tell me about 4/4? It's one whole. Yes, you were right. 4/4 is the same thing as one whole. So if you take 4/4 and you multiply it by 1/3, what are you going to get? So you would get 4/12, which is the same thing as, if I had to simplify this, you would get 1/3. Okay? Well, if 4/4 is the same thing as Hunter, your fingers are not that great. If 4/4 is the same thing as 1, if this is the same thing as this, 4/4 is 1. And I multiply it by 1/3. What will you get? What will you get? Say it loud and proud. 1/3. So if I know that 1 times 1/3 is 1/3, what can you say about 4/4 times 1/3? It's 1/3. Did you even really have to do the work? Why not? Think about it for 1 second. Look at the numbers. Look at what you multiply by 1/3.
Like how 1 times 3 is 3. 1 times 1 times.
How do you know it's 1 times 1/3?
1 times any number equals.
How do you know it's 1? Bingo! 4/4 is equal to 1. Anytime you have your numerator and your denominator the same, it's equal to 1. Did you have to do the math? No. So if I have 5/5 times 6/10, what do I automatically know my answer is going to be? 6/10. I didn't even have to do the math. Why do I have to go through the trouble of saying that it's 30/50ths and then have to simplify it? That's more work. I already know 5/5 is equal to 1. So I can say that this 5/5 times 6/10 is equal to 6/10. But I'm not even worried about that right now. You're taking it one step farther than I need it to go. So, because this is 1, my fraction will stay the same. Are you following me? Okay? So, the next part. Yes, ma'am. You should be writing this down. Anything that I'm writing up here, you should be writing. Anytime your numerator and your denominator are the same, it is equal to 1. And when you multiply it by something else, this fraction or number will stay the same. So if it's 4/4 times 1/3, I get 1/3. 5/5 times 6/10, I get 6/10. It will stay the same. Regardless, it will stay the same. Are you with me?
Yes, ma'am.
All right. Have you written this down? Awesome. Because I'm going to erase it. Because I don't want to add another page yet. I don't want to go on to the next page. Okay. That's an awfully blank piece of paper. Because you're not going to remember this. Okay. So, if I put, I'm going back to the 4/4 times 1/3. We already decided that 4/4 times 1/3 was 1/3. So now, if I change, this is my scaling factor. This is what determines the size of this fraction. Okay? Scaling factor is my size factor. Okay? It decides whether or not this gets bigger, smaller, or stays the same. It's not really important, but it is. If I change this fraction, what if I make it 3/4 and I multiply it by 1/3? Will this, watch what I do. Watch what I do. Don't even worry about working it. Don't work it. What symbol can go in here? Will this be greater than, less than, or equal to 1/3? If my scaling factor is 3/4, will my product of this side be bigger than, less than, or equal to 1/3 over here? If I'm multiplying by 3/4. Up here, I multiplied by 4/4, and it was equal. Now I'm multiplying by 3/4. Will this product be bigger than, less than, or equal to? How many of you think it's going to be equal? Why would it not be equal?
Because there's a 3 and 4. 3/4, and so you can't say 3 times 1 is 1. You have to say it's 3.
Okay. So already you can tell that this is a 3, that's a 4. I'm not going to get the same answer. 3/4 does not equal 1, and that right there is the very reason that you need. 3/4 is not equal to 1. 3/4 is not equal to 1, so my fraction is not going to stay the same, is it? No. It's not going to, it cannot be equal because this is not equal to 1. So my fraction is either going to be bigger or smaller. So how many of you think my product is going to be bigger? See, I told y'all you could do it. How many of you think it's going to be smaller? Why smaller? Because 4/4 is bigger than 3/4. Because 3 is smaller than 4. 3/4 is smaller than 1. Because I need 4/4 to make 1 whole. Isn't this less than 1 whole? Since this is less than 1, my product, my total product is going to be less than this. I don't even have to work it. I can just look at this, my scaling factor. What do I need to make 1? I need 4/4. Is 3 less than 4?
Yes.
Yes. So this is less than that. I don't even have to work it. So this ends up being bigger. because this 3/4 is less than 4/4. Put the desk down. What if I have 5/4 times 1/3? 5/4 is my scaling factor, and I'm comparing it to 1/3. How will my 1/3 over here, my product, compare to 1/3? 5/4 times 1/3. So 5/4. Think about that fraction. So rather than trying to work it, look at your fraction. Your scaling factor. Now, a couple of you have already figured it out. What do you know about 5/4? How does it compare to what you need to make 1? It's bigger than what you need to make 1 whole, right? So if this is bigger than 1, is this product going to be bigger than that? Yes. So just like if I have 1 and 0, 0, 0, 0, 0, 0, 1 times 5, it would be bigger than 5. Not a whole lot bigger, but still bigger. $5.01 is more than $5. Not a lot bigger, but still bigger. Greater is greater. Bigger is bigger. Okay? So let's try another. Oh, geez, so let's compare. Okay, what symbol goes in this circle?
Equal.
Equal. Why?
Because 5/5 is 1.
Because 5/5 is 1, and 1 times 1/2 is equal to 1/2. Is that what y'all got?
Yes.
Because when your numerator and your denominator are the same. 3/5 times 1/2 is what to 1/2? Less than. Why? 3/5 is less than 1. If this is less than 5/5, you always compare this to what it takes to make 1. If this is less than 1, then your entire product is going to be less than what you're looking for, than your original number. You should have that. So if this is less than 1, then your entire product is less than your other side. 9/5 times 1/2, how does that compare to 1/2?
It's bigger.
Why? Because 9/5 is greater than 5/5. It's almost double. It's almost 2. Because it's almost 10/5. 9/5 is greater than 5/5. And since that's greater than 1, the entire product is greater than 1/2. Are there any questions so far? Any at all? Yes, ma'am.
Wait, so it'd be 2.
But it would still be greater than 1/2 because you're just comparing it to your original number. As long as it's greater than 1. It doesn't, the product really doesn't matter. You're just comparing it to 1, whether or not it's equal, less than, or greater than. The product really doesn't matter. Did I answer your question? Okay.
Well, the number's too big.
Yes. Okay. So here we have somewhere we have fill in the blank to make the sentences true. So we have 7 times something over 4. That is less than 7. So this is our original number. Our scaling factor is something fourths. So something over 4. But we need to make the product of something times 7 less than 7. So what can you multiply by 7 to make it less than 7? What can you multiply by 7 to make 7 smaller? What can you multiply by 7 to make 7 smaller? Yes?
0.
Okay, so I can have a numerator of 0. What else? There are a couple answers you can put here.
1.
I can do 1. What else? I can do 2 and 3. Can I do anything else? No. As soon as you hit 4, you're multiplying by 1 and you would have an equal sign. So you could have 0, 1, 2, 3. 7 over something, 7 somethings times 15 is greater than 15. So we're having to multiply 15 by something to make 15 what?
Oh, there.
Bigger. We're having to make 15 larger. So we have to multiply 15 by something to make it larger. Think about your fraction, what you have to do to it to make it bigger. And if you can't remember, look back at your notes. You should be taking good notes. Otherwise, it doesn't do you any good if you're taking bad notes. Because you need this. Eli, what can you put under 7?
8.
If I do 7 eighths,
Oh, no.
am I going to make 15 larger or smaller? I'm going to make it smaller. Here,
5.
7 fifths. Good. Here, I think you got it, and you were thinking you couldn't. Look at you, Mr. Man. All right, yeah. 7 sixths. What else? 7 over 1. What else? 7 over 4. You figure it out now?
Yes.
What? 7 over 2. 3. 1, 2, 3, 4, 5, 6. So anything that would make the fraction improper. Can you do 7 over 0? No. So anything less than 7. 7 over 6, 5, 4, 3, 2, 1. 3 times something fifths is equal to 3. What would your fraction be to make that statement true? I'm going to call on someone different. I've got the same people raising their hands. Think about it for a second. I'm going to call on someone different. The same 4 people raising their hands. What can go in that blank? Andrew. 5. Because you need it to equal 1. You need your numerator and your denominator to be the same so that it is, in fact, equal. Can anything else go in that blank? No. If you put something else in there, you're going to end up with a greater than or a less than. And you can't have that. So, was this as hard as y'all thought it was going to be and you started freaking out? No. Do you have to pay attention to what you're doing? Yes. And that's what's going to get you, because sometimes you don't pay attention to what you're doing. Case in point. Shame, shame, shame. No. Okay. Look at the inequalities in each box. Inequalities just mean when you've got greater than or less than. That's all that means. When you see the word inequality, that just means something is not equal. If you ever see me writing something like that, that means not equal. Because sometimes on your test, I see things that look like this. And I'll go, 2 times 3 does not equal 5. That just means not equal. So inequality, this or this. So look at the inequalities in each box. Choose a single fraction. So this is where you've got some wiggle room, but you've got to make sure your fractions are right. Choose a single fraction to write in all 3 blanks that would make all 3 number sentences true. Now, you don't have to explain how you know, but if I call on you to answer it, you do have to let me know how you knew what fraction to put in there. So the first one, you have 3/4 times something is greater than 3/4. You have 2 times something is greater than 2. And 7/5 times something is greater than 7/5. Okay, Jasmine, did you do a fraction for 3/4? You leave a blank? Tanaya, what'd you put in there? Huh? Will multiplying by 2/3 make 3/4 larger? Here, what'd you put?
1/3.
Will multiplying by 1/3 make 3/4 larger? Because we've got to make it greater. You guys are doing it the wrong way. Huh? 4/4 multiplying by something that's 1. Would that make it larger? Andrew.
1/4.
1/4. Would that make it larger? You aren't really paying attention to what you're doing. Hi. 3/2, which is bigger than 1, would make this larger than itself. You didn't go back and look at your notes, did you? Alea, what'd you put? Huh? 9/7. If you make it bigger than 1, you make the fraction bigger than itself. Quinn, what'd you put? 4/2. Improper. Daniel? 6/5 to make it larger.
5/10.
If that would be like multiplying 3/4 by 1/2. If you multiply 3/4 by 1/2, are you making it bigger than 3/4? I do 3/4 and I cut it in half. Am I making 3/4 bigger? Nope, I'm making it smaller. Okay, Jaden, did you do anything? Okay, so all of these, if you notice a trend, the fraction is larger than 1. If you need to make it greater. So what can we do to 7/5 times something to make it bigger than 7/5. Try this again, Andrew. Huh? 8, 6. The same exact fraction?
No.
Huh, how funny. Okay.
So you can only use one fraction.
All right. Huh? I thought you said 1/2. I was like, wait a minute. Okay. So all of these, again, have to be improper, bigger than 1. So if you give me something like 3/4 or 1/2 or 5/6, are any of these bigger than 1? No, they have to be improper. If you give me 4/4, is that bigger than 1? That is 1. So it's not going to work. So you would have to do something like the 3/2, 9/7, 8/6, 6/5, 4/2. Any of the ones that were up here that are larger than 1. It can be the 4/2, because 4/2 is like 2, right? Isn't that bigger than 1? Yes. So I can do 6/3 if I want to. Still bigger than 1. Still bigger than 1. Okay. Now, if you look at these, is it greater? It's less than. So what fraction could you come up with that will make 3/4 less than 3/4? 2 less than 2 and 7/5 less than 7/5. So, Myra, what fraction did you do for 3 times something is less than 3/4 times something is less than 3/4? What'd you put? So 2/4. Kylie Gordon, what'd you put? Did you put anything? Because you should just be able to look at it and tell me something. What'd you put? Huh? 1/3. Talk so softly. Zanaya, what'd you put? Zach, what'd you put? 4/4 is equal to 1. So that would make it equal. Daniel, what'd you put? Mia, what'd you put? Is that less than 1? Yeah, your numerator is less than your denominator, so it's still less. I mean, you could do like 9/10. You could do 99/100. It's still, if your numerator is less than your denominator, it's not 1. 999/1000, it's still less than 1. Please don't do fractions like that. I hate it. So, as long as your numerator is less than your denominator, it's less than 1. As soon as you make them the same, it's 1. Well, if I need to make them equal, well then that's one thing. But if I need to make it where it's less, you need to make your numerator less than your denominator. But please don't try to impress me by making really huge fractions, because it's harder for me to read. Make them like normal, regular fractions that we would use, because this kind of stuff, it gets to be too much to read. It gets to be too much. Okay. So you could use these fractions here and there. And it doesn't even matter that this is improper, that that's 7/5, because I'm still trying to make it less than 7/5. It does not matter that this is improper. If I take 7/5 and I multiply it by 1/2, it's going to be less than 7/5. Doesn't matter. So I'm just taking that end product of 7/5 times 1/2, and it's going to be less than the original 7/5. It's going to be less. So Johnny says that multiplication always makes numbers bigger. Always makes numbers bigger. Explain to Johnny why this isn't true. Give more than one example to help him understand. So, is he wrong? Yes. It's really hard to say always in math because I can't say that 2 plus 3, is always 5. Because, 2 plus 3 is 5, but is that the only way to make 5? No. And I actually had someone show me that, what was it? 1 plus 1 is 3. She had like this mathematical thing that was like this long, and I was like, stop. Please don't show me that ever again. So she's really smart. She's a cousin. And I was like, don't ever show me that again. 1 plus 1 is 2. But does multiplication always make numbers bigger? Why is this not true? You should be able to explain this to me. Why is this not true? Give me one example why this is not true.
Because because if you do 1 times 1, that's 1, and then you
So what does that example mean?
The 1 is not bigger than 1. 1 is not bigger.
So it is equal. So in this case, it was equal. It stayed the same. It didn't get bigger. So when you multiply by 1, it stayed the same. So when you multiply by 1, it stayed the same. So what is another example that multiplication does not always make a number bigger?
0.
Okay, so if you multiply a number by 0, what happens?
It makes it less. 0.
It makes it less. All right, so what would be something else that we could say? Daniel? Okay, well, you need to be a little bit more specific because I can do something like 5/7 or 9/7, and I'm getting two different things. One makes the number bigger, one makes the number smaller. There you go. So if the number is less than 1, because this one was greater than 1, and it does in fact make the number bigger. So you can't just say fractions. So you have to be really careful. So I'm going to change yours just a little bit, Aaron. So when we got 0, we're going to say numbers less than 1. Because 0's in there, any number less than 1 makes the numbers less. It could be anything less than 1. Huh? Any number less than 1. Denaya cannot see when you're on your feet. So if I had 999,999 over 1,000,000, that's less than 1. That's a fraction that's less than 1. It's a big old honking fraction, but it's less than 1. Because in order for it to be, a 1, it needs to be 1,000,000 over 1,000,000. It's a hair less than 1, but it's still less than 1. Yeah, those would be some teeny tiny pieces. But my point being, any number, because one of the things that you guys struggle with, and I don't want to say you in general, but I'll say 5th graders in general, have a really hard time with this kind of number concept, with realizing that this is less than 1 and multiplying a number by this, if I did that would actually be less than 5. Because it is. This is less than 1. Now, is it a lot less than 5? No, it's like that much. Is this less than 1? Yeah. So is that less than 5? Yes. Is it a super duper lot less than 5?
Nope.
No. But less than 5 is less than 5. Because they're not asking how much less. They're just asking, is it less? Just like if I did 5 times 1, 2, 3, this over 1, 2, 3, 4. I had to count that. Comparing those two, would that be greater than, less than, or equal to? It would be greater by that much. That's like $5 and a penny compared to $5. This is when students tend to get arguey with me, argumentative, and they would go, but it's just a penny. But it's just a penny. It's still something. A penny is still more. If I had $5.01 and you only had $5, I still have more money. It's just a penny, but it's still more. So you kind of have to let go of the, but it's just. More is more, less is less. Equal is equal. So this is the one thing where some of you are really going to have a hard time, because with the number concept, the number sense part of it, you really, I don't think you're really going to get this. You will in the decimals with the 9s. There will be some decimals with 9s. You're like, oh, but I'm multiplying by decimals, and there's a whole bunch of 9s. Yeah, but are they all behind the decimal? If you got, all of those, is there anything in front of the decimal? No. So it's less than 1. So it's still less. This is where you guys are going to really, I don't want to say all of you, but you're really going to struggle with this, because you're really going to want to argue with me on this one. And not all of you. Some of you are like, all right, it's less than 1. Awesome. A company uses a sketch to plan an advertisement on the side of a building, like a big sign. The lettering on the sketch is 3/4 of an inch tall. Now, this is a real world thing. So, what did you get?
25 and 2/4.
So, did it go in evenly?
No.
No, so do you have to take into account your remainder? Yes. So 34 times 4. Now, one thing you could have done, now 4 does not go into 34. However, you could have 2.0'd it by 2, because 34 is even. So 2 goes into 4 2 times. 2 goes into 34. 17. You didn't have to do that. I just know it. So 17 times 3, 21 to 55. I'm just doing it because I'm showing up. 2 and 51. 2 goes into 5 2 times. I'm going to do it the other way too. 2, that's 4, and 11, 5, 10, 25, and 1 half. So if you did it the other way, that's 16, 12. Why did I do multiply that by 4? Oh my gosh. I was like, where did that number come from? 34 times 3. Let's try that again. 12, 1, 102. See, and then I even caught it, and I was like, where did that number come from? What am I doing? Okay. And then 4 into 102. 4 cannot go into 1. 4 goes into 10. 2 times 8. Leaves me with a remainder of 2. Bring the 2 down. 4 goes into 22 5 times. That's 20 with a remainder of 2. And I don't go 25 R2 because what am I just going to take those 2 inches and just kind of throw it off to the side and be like, okay, I'm totally done? It's 25 and 2/4. The way some of y'all take into writing stuff, you would go, oh, they're 2 inches tall. Because you would take this and make it your whole number, which is not how we do it. 25 and 2/4, which needs to be simplified, and 1/2 inches tall on the building. Jason is drawing the floor plan of his bedroom. He is drawing everything with dimensions. Dimensions are just like the measurements that are 1/12 of, 1/12 of, there it is, 1/12 of, fraction of, the actual size. His bed measures, so if you have your bed, 6 feet by 3 feet. Area. Look at that. That's not perimeter, that's area. 6 feet by 3 feet. Area. You did that in 4th grade. His room measures 14 feet. So this is a multi-step problem, isn't it? By 16 feet. So when you see the by, what does that mean you're supposed to do? Multiply. So that's area. Sure hope you guys remember how to multiply 2-digit numbers. Oh, that anchor chart's still up there. And you guys didn't have it in your binder. What are the dimensions of his bed and his room in his drawing? Do not forget the dimensions when he drew it, 1/12 of the actual size. So you can't just do this and call it a day. See what you get.